All right. All right, everybody. It's about time. All right, good afternoon, everybody. Are you ready? All right, good afternoon, everybody. All right, we're gonna start. All right. Definitely what we want to look at is we're gonna be looking at bearings, right? But just before we start working the problems that you get on Csec for bearings, we want to kind of look at some quick ideas that you will be using, as well as tools that are necessary in order to do bearings well as you go. All right. So I'm just going to remind us of a few things. Take a few minutes to look on the things we need as we are about to attempt questions. So one, you want to at least remember that bearings will always be about triangles, right? So with triangles come what we call trigonometry. So we want to learn all the trig ratios and all the trig rules, right? So trig ratios are needed whenever any right angle situation comes, right? So if we have, if our bearings end up to be a right angle, where we have angles and sides, we're thinking about trig ratios to help us to go through that, right? So this is in the event that we're looking at triangles with right angle. When we have triangles that are non-right angles, right? So we don't have a right angle triangle, then we want to look at trig rules. So we have the rules which are different from the ratios. So trig ratios deals with what we'd call the soccer tower, right? So this one with the right angle triangles, we look at soccer tower. So we're talking about the sine of an angle deals with the opposite and the hypotenuse. Cosine of the angle deals with the adjacent and the hypotenuse. The tangent of the angle deals with the opposite and the adjacent. But when it's not a right angle triangle, we're talking about our cosine rule or the sine rule. So the cosine rule, and I must say that this one is used so much all over the place. Let us say that we have an angle in this corner, and we have a side A and we have a side B. And we are asked to find this side opposite to the angle. Now, whenever we have this case where we have an angle and it's between two sides, and you want to find the side opposite to that angle, we want to use this. It is said that, let us say we call this side X, right? Let us say we call that side X. It is said that X squared is equal to a squared plus b squared minus 2ac, 2ab should say times the cosine of the angle between those two sides. So the moment you have a situation with an angle between two sides, or if you know everything in this corner, all right, we use the cosine rule to help us out. And it's going to come out a lot. You're going to see where the cosine rule will be used so many times. Now, let us say that it's still not a right angle triangle. So, and then we don't have an angle between two sides, right? For example, let us say we have this side here, right? And we have this angle here. And for some reason, we don't know this side, but we do have the angle here, right? So we have the angle at B, we have the angle at A, and we have a side opposite to A. For example, we have that side, right? Now, if we're asked to find this side, which is opposite to B, and I'm going to call it little b, as long as we are able to establish a relationship between sides or angles and sides opposite to it, if we can find two pair, all right, and if one of the elements is missing, we're good to use the sine rule. So the sine rule is used when we're dealing with angles and sides opposite to it. And if that's going to be the case, you will get, for example, I'm just making this up, you will get, for example, let us say this angle is 70 and you're told this side, and you might know this angle to be 60 and you want to find that side. So we are referring to a case like this where I have this angle, I know the side opposite to it. I have another angle, but I'm in search of the side across from it. So whenever the sine rule will be used, it's going to be an angle and this opposite side. It's going to come out a lot, right? It's A over the sine of A is going to equal to the value of B over the sine of the angle at B. This is what we will be using. So I want us to relax and look on how these things will be coming out a lot of times. Now, one of the things that you want to remind yourself of is the Z angles, co-interior angles, right? And when we say Z angles, we are referring to an idea like this. Let us say I have one line here, which is my north line, right? And somebody travel from here, let us say this is A, and you travel to B here. There's another north line at B. Now, if we have this, and if I know this angle here at A, right? Now, we might be told that the bearing of B, let me put B closer to, let me put B right here at this spot right here. Now, if we are told that the bearing of B is this angle here, the bearing of B is that angle right there, I can find the bearing of A from B. So the bearing of A from B is going to be all of this angle from B in a clockwise direction leading back to A, right? So again, if I have this angle here, which is the bearing of B from A, then I'm able to find the bearing of A from B easily, right? Like that. Now, how does the Z angle help you out? You're going to have to be looking out because it's going to show up a lot. For example, this is a north line and there is another north line somewhere. And for some reason, you travel like this. When we say Z, we're not necessarily saying you're going to see a pretty Z looking at. All right, we're just saying that the idea of the Z. So if I know this angle here, if this angle here is 20, then this angle under here is going to be 20 as well. This is the Z that we're referring to. It may not be a perfect Z, it might be an upside down Z, but we're saying that Z angles are equal. It's called alternate angles, right? So whenever you're bounded between two parallel lines, you're cut by another line, you're going to somehow see a Z coming out. We are saying, look out for it because Z angles are equal. So the fact that I know this angle, right, then I automatically will know this one. It's what we call the Z angle. Another way that it may look, all right, is let us say I have a line like this and I have another line like this somewhere down here. And these two lines are parallel and it's cut by another line. I'm suggesting to you that this angle here will be the same as this angle. So if I could take a time to show you here, this is what we mean. You're still seeing this sort of Z, right? So this angle here, if it is 50, automatically this becomes 50, right? And if this angle here becomes 130, then the angle on the other side here becomes 130 as well, right? So if you want to look at what that Z look like, it may not be a perfect Z, but take a look at this. We're talking about that idea, right? So we want to make sure that we're seeing those, we're using them to help us to guide our thinking. Now, there is one called the co-interior angle, and sometimes it's going to be your only way out to start. If I know an angle here, the fact that these two lines are parallel and all north lines are parallel to each other, east-west lines are parallel to each other. I'm suggesting that if these two angles, if I call this A, this angle here, if I call it B, angle at A plus the measure of angle at B, they do add to give 180 degrees. So the moment I start from a point, let us say I'm doing my bearing and I draw up this is C, and for some reason they sent me on a bearing of say 60 degrees here. And I go here, right? Now, when I go, this might be D. So if I should draw back my key, which is what will be leading me, guiding me, we're suggesting that the angle here at 60, all of this angle at 60, combining with this angle I'm going to put in black, they add to give 180 degrees all the time. So sometimes you will need that to help you out to find solution. So this would be 120, right? Because the two angles, they are called co-interior angles, and they do add to give 180 degrees. Those are some of the stuff that you would have had to learn before you try to respond to any bearing question, because when the question comes, you will be needed to put things together as you go forward. Let us take a look at the first question. So we're actually going through the questions from CXC, right? So here is a question we're looking at. So this question reads, it says here, the diagram below shows 4 points, P, Q, R, and S on level ground, where pillars will be placed to mark the outline for a foundation. So they're gonna mark some foundation. And when there's a pillars, they're gonna erect things there. Now, we're reading information. So now we have some information down here. Information says that there is a vertical post RT, right? A vertical, so we're told vertical post RT, right? At R. So wherever you have R, you're gonna erect that RT. Now, more information. The angle of elevation of the top of the post T is 21. All right. Find the height of the post. All right. All right. So we want to look at that quickly. We want to look at that very quickly. So what you want to do is to read to make sure that you have all the information to go. And very importantly, you're told here that you're on level ground. So the diagram below shows 4 points, P, Q, R, and S, and these are on level ground. So it doesn't matter if it doesn't look like it is level. It is on level ground, right? But it's because they're trying to represent it on this flat thing, right? All right. So we have some pillars. So we have P, Q, R, and S. So down here now, it is said that there is a vertical post RT. So we're talking about the post is RT, it's vertical. So from R going up in the here to T, there's a vertical post. And they said from Q, so this is very important, from Q, angle of elevation. So now you have to think, all right? So if I could drop this right beside what we have here, probably I could put it on this side. They brought Q in the mix. So let us say this is the point Q. This is the point R. So there's a line from R, from Q to R, right? And then now they're erecting a T. So this is T up here. They erect a T somewhere up there. Now they gave us more information, and they did say the angle of elevation from Q to T is 21. So you could see that completion of that triangle. Elevation would be down here. I think they said it's 21 degrees. Right here is 21 degrees. And you want to notice that you have 153 meters, right? You have that. And whenever you have level ground and anything that is erected, right, you will end up getting a right angle triangle. So here it is, we have a situation with a right angle triangle, right? Now, the moment I have a right angle triangle, I will be thinking the trig ratios, all right? So the question says, find the height of the post. What are they referring to? We need to find this distance here, all right? We need to find that distance right there. This is what we need to find. We need to find that. All right, so you could look, do the relationship, right? Now, for this that we want to find RT here, it is the opposite side to 21. So you could see 21 opposite, all right? And what else we have for 21? We have the adjacent side to 21, right? So we want to find the opposite side, and we have the adjacent side. So we could start off by remembering which one of those rules. So you could look at SOHCAHTOA. So it's going to be the T, because we're dealing with opposite and adjacent, tangent. So the tangent of the angle in the right angle triangle is going to equal to the opposite side divided by the adjacent side. So we could push this forward. Tangent of the angle, which is 21 degrees, is equal to the opposite side, which is RT, which is the height of the post. RT, opposite to 21, over 153. So we want to make sure that we have the measurement. This is the 153 that we have right there, right? Now, all we're going to do is to take our calculators out and work out the math. But in order to find RT here, as you could see, if I do multiply both sides by 153, then RT will be left alone on the right side. So on my calculator, I need to put 153 tangent of 21, right? And it's going to take me to the answer. So we're looking at 58.7, and we're dealing with meter, and that is the height of the post RT. Make sure that you are following instructions. If they ask for a specific rounding off, they didn't ask, so the answer is 58.73. So you could say 58.7. All right, we could use 3 significant figures for the final answer. So that is the answer there. All right. Remember, if you're working and you feel like you have the answer, you could actually drop the comment, drop the post, drop your response in the chat as we go forward. So let us look at the second question. Now, the second question says, given that QS is 135, I'm going to stop and put this on now. QS is 135 from Q to S. So I am going to be putting on 135 on that. So we were given that measurement right now, right? So given that QS is 135, right? They say calculate the perimeter of the foundation PQRS. I need to find the perimeter, the distance along the boundary. Now let us take a quick look at what it is that we need. When we talk about perimeter, we're talking about starting at R. If I should start at R here, I will be going along here. That's 153 that I know. Then I'm going to come along here. That's 83 that I know as well. I need PS. I don't know that, but I definitely know from S to R. So we're actually marking out that foundation. We need to add those distances, but we have 3. So there is only 1 that is missing. We need to find this one, right? So it's our intention to find that. So as you could see, we're going to be utilizing what we know now, right? Because I have an angle 29, which is between 83 and 135. So the cosine rule is what I'm going to be using now to help me to find PS, and then I add everything up. So we are in search of PS. Let us quickly drop what this actually looks like right about now. So what I'm going to do, I'm going to create a quick little diagram, right? I'm going to create a quick little diagram at the spot where I'm going to work out this, so I don't have to come back to it too often. So I'm going to just put a quick little diagram here. So I'm going to pick off the part that I'm actually dealing with. I'm dealing with a shape like that. And this is where Q is. This is where P is. And then S is somewhere out here. So we're actually dealing with this. This is where the 29 is. Remember that this is 83 and this is 135. I'm saying this is one of the cases. It's not a right angle triangle, but I do have an angle between 2 sides, or I have everything in the corner Q. So the cosine rule will help me to find the distance opposite to the angle PS. So we'll start off by saying PS square is equal to 83 square plus 135 square minus 2 times 83 times 135 times the cosine of the angle, which is 29 degrees. Those are the figures that we need to put together, right? So let us take our time and make sure that we employ the working hour properly. When we square 83, we're going to get 6889. And when we square 135, we're actually getting 18,225. Now, we're going to be putting all of this on our calculator one time. So the -2 times the 83 times the 135 times the cosine of 29 will be placed on the calculator right now, right? So we have to make sure we're not making any error. -2 times 83 times 135 times the cosine of 29 degrees. Make sure your calculator is in degrees, and we're going to get a -19,600, and I have 0.2. So what we want to do is to work out this. So PS square is going to equal to 6889 plus 18,225. And we want to take from that 19,600.2. All right, so we're looking at 5,513.8. Now, in order to find PS, we want to take the square root of both sides. So PS is going to be the square root of this number. And we're getting 74.3. So let us put this on here. So this is 74.3. Remember, though, that we're talking about the perimeter. So the aim is to find the perimeter. And it's going to be everything, including the 74.3. We're going to be adding those. So let us go back for those measurements that we had before. So we could take a quick look on the measurements that we had before. There was a 153 there was a 110, and there was also a 83. So what am I referring to? I'm referring to these sides, 153, 83. This is now 74.3, and the 110. The distance along the boundary, do not mix it up with this. This is not a part of the perimeter, right? All right, so we put those together and our final answer will be it. 74.3 plus 153 plus 110 plus 83. And we're looking at 420.3, and I believe it is in meters. And that's the perimeter right there. All right, so as we go, we take our time, making sure that we're not making any errors as we go through. All right, guys, remember, if you have not yet subscribed to the channel, do so. As well, if you have not hit likes, we're asking you to do so right now. All right, let's continue working. There's another question here. All right, so this other question says, from a port L, ship R is 250 kilometers on a bearing of 65. From a port L, ship R, all right, is on a bearing of 65. We were also told that ship T is 180 kilometers from L on a bearing of 148. This information is illustrated in the diagram below. So we're looking at most of the information. They left off the bearings. They gave us the distances. Fine. The first question says, complete the diagram above by inserting the angles, the value of angle O, RLT. So they want us to just insert RLT. So RLT is this angle here. They want us to insert the value of this. All right, so what we have to do now, in order to insert the value here, we need to actually remember what they just said, read it back, put them on, and then look at how we're going to be getting this angle here, right? So let us look on the bearings that we got. First information is that we got here that from L, ship R is 250 kilometers on a bearing of 065. So we're talking about all bearing are from the north of the point. So from L, you step up to the north line and you do a clockwise rotation, 65 degrees, and you are getting the bearing that will lead to R. So we want to put that on. Also, we got the bearing of T. We were told that the bearing of T would be 100, and it's 148 from L. So all of this going around is 148 in blue. 148. So you're looking at your angle in blue, looking at your angle in red. Now, in order to get this angle that I'm going to shade it with a blue right here. This little piece that we want here is going to be the difference between the two angles that we just have. So if I take 148 and then subtract the 65, then I'm going to find that angle at RL. All right, RLT. So it's 148 and you're taking 65 from that. So we are now told that this is 83 degrees right there, that angle. So sometimes you're not going to get everything, but you're supposed to be able to put the things together in an effort to figure out what goes on. So if I get two bearings from one point, I'm able to find the angle between, all right? So we can always employ subtraction and we're good. So this would have been 83 degrees right there. Now, let us look at this other question. So the next question says, calculate RT, the distance between the two ships. So as you could see, they want us to find the distance between the two ships. All right, so what I'm going to do quickly is just to drop back a diagram here so that we could quickly see what's going on. So basically we have this and we have this, right? And we have a case like that. This is 83. This is L, this is T, and this is R. So that's what we really have. We got 250 here, kilometers, and we got 180 here, km. Again, remember the introduction, we looked at the fact that we will be given a lot of questions that will be utilizing cosine rule, sine rule, and so on. Again, this is the cosine rule being used. Why? Because I have everything in the L corner. I have an angle and two sides in the L corner right there. Or I could say that, listen, I have an angle between two known sides. And I'm asked to find the side opposite to that angle, RT, which is actually the distance between the two ships. One ship is at R, another ship is at T. So the distance between them would be from R to T. So let us go about finding RT by using the cosine rule. So here is the cosine rule. RT square is going to equal to, putting on the numbers, 180 square plus 250 square minus 2 times 180 times 250. And this will be multiplied by the cosine of the angle between them, which is 83 degrees. So you're setting up this in an effort to find a value for RT. But for now, RT is squared, that is okay. Let us continue putting on some measurements. So what we're going to do now is to make sure that our calculators are working well. We want to square 180, and we're thinking about 3, 2, 4, 0, 0. We want to square 250, and we're looking at 62,500. Now, at this moment, I would say to us, let us put all of this on the calculator one time. All right? My bad. Let me take off that. All right. Let's put everything here on the calculator one time. Talking about -2 times 180 times 250 times the cosine of 83. Let's put that on. -2 times 180 times 250. And we want to multiply that by the cosine of 83 degrees. And we're going to get to minus, let me use my right marker, blue. We want to minus 10968.2. So let us work this out. 32,400 plus 62,500. We want to take from that 10,968.2. And we're looking at 83,931.8. All right, good. So there it is. That's what we have there. So in order to find RT, what we're going to do, we're going to take the square root, right? We're going to take the square root of this number. So let's take the square root of that number. And we're getting 289.7 km. So I have 289.7 km, and that is the distance between the two ships. So this is 289.7 km right there. Now, as you could see, we are employing a similar thing like what we just did, right? Let me label this diagram. We got 289.7 89.7 km for that. All right, so there it is. There it is. Again, when we're going through these, no rush. We have to slow ourselves down, look at what we have. You're going to see a repetition of the ideas, though. I will tell you, you see a lot of repetition. See a lot of repetition coming out in terms of what is being used to assist you to solve the problems. It's limited because you're in a world of triangles, and it's limited things that you will be using. So you go for them each time. Let us see what the next question is about. The next question says, what we want to do is to determine the bearing of T from R. So we want to determine the bearing of T from R. I'm going to go back to the original diagram to look at this. Bearing of T from R. So we have to remember that. Bearing of T from R. All right, so this is what we want. Bearing of T from R. So here is R. Let me minimize this just a little bit. All right, let me get some more from it. All right, good. So we want to find the bearing of T from R, from R, from R. So at R, what you want to do is to draw up your north line, just to show, give yourself some direction to what you want. So the bearing of T from R will be all of this. From the north of R, you want a clockwise motion until it touches a line that leads to T. So this is what we want to find. We want to find that. And if we find that, then we would have gotten the bearing that we need. So I'm going to put it in green right now. We want this, right? That's what we want to find. The bearing of T from R is my angle in green. When you really look at it right now, right? I'm thinking that at any point that you have, right, it's always 360 degrees. So for example, if I'm at a point here, and if this is what I want, if you think about completing the circle, you have a total of 360 degrees. So sometimes when you want something, you're not always going to go directly there to find it. You could find the other parts that you don't want and pluck them out. So in this case, what I'm going to employ is that I am going to find this part. I'm going to put in pink here. I'm going to try to find this. And if I pluck that from 360, if I take that out of the 360, I will be left with my green angle, which is the bearing, right? I will be left with this part, which is the green part. So that's what we want to think about. If I find that pink piece and pluck it off, I am left with the green piece, right? So, so let me mark this angle here. Let us take a quick look at what's going on. Now, I am able to use co-interior with 65 to tell me everything here. Remember, we had said in the introduction that if I have the value of this angle here, if I have this, I am able to tell the angle between that helps to form that 180, because co-interior angles would add to give 180. So let me put a color here, which is different. I'm going to put this blue. I am able to tell the blue angle right now. So the blue angle will simply be 180, take away 65. So if I have 180 and I take out 65, this is 115. So I do want some, I need that. So that is part of the angle that I'm going to pluck off to throw away, right? So I know 150 will be taken out to throw away because we're focusing on the green and we targeting 360. But what is missing will be this little piece in the triangle. If I should find that little piece in the triangle and pluck it out along with 115, I would have plucked off this entire thing here. So this piece is the angle in the triangle plus 115. That's the part that I want to take out and throw away. and then I'll be left with the bearing. So a lot of times, sometimes you work like that. Allow me to work out this. I'm going to put that angle in a color. I might use yellow. So I want to find this yellow angle, which is a part of the triangle. So when I find that yellow piece, I'm going to add it to that 115. Then I take it from 360 and I'll get the bearing that I want in green. I trust that you're seeing, because I'm trying to use the colors to help us to better see what we're pulling apart. Now, let's focus on the triangle. So if you don't see the triangle, take a quick look at the triangle that I'm referring to right here. Here is the triangle. The triangle that we're going to focus on is going to be from R to L to T back to R. I want to focus on that triangle, and I'm going to find the angle at R in the yellow, and then I pluck it out along with the 115. So you could see the full circle right there now. There's a green, yellow, and blue that would have made 360. We're going to take the blue and the yellow out of 360, and we're left with the green, which is the bearing. So I want to, for one more time, I'm going to just mark that this is the bearing that I'm looking for right there. The bearing is in green, right? So let us go about finding this. But it's not a right angle triangle. But you remember earlier on when we were speaking about how do we know what to do? Well, you have a triangle here, right? And if I should quickly help us to see the triangle more clearer with less distractions, all right? So let me pull off all of these unnecessary things just to put back my triangle here. Here it is. We know that this is 250, but let's put the things on it that we are. Let's leave it. There is 180 here. There is an 83 here. And there is this angle here. Over here is 289.7 right there. Now, we might not need this 250. I want us to focus on what we want. So this is the piece in yellow. That's the angle. Let me go back, get my yellow angle there. Angle in yellow, all right, right here. We want that to add to the 115. So let us take a closer look on everything that's going on, right? So if you really look, we have this angle and we have the side opposite to it, right? I need this angle, but I have the side opposite to it. And that is the principle that we were saying. Whenever we're seeing angles coming out on opposite sides, it's going to be sine rule. So the sine rule says A over the sine of the angle at A is the same thing as B over the sine of the angle at B. What do I mean? All I'm going to do is to employ this. Watch. We're going to start off by saying 289.7 over the sine of 83 is equal to 180 over the sine of the angle that we don't need. So I'm picking on the pairs, an angle on the opposite side. And as long as I know one pair fully, which is the 289.7 and the 83, I'm able to make a connection with another pair, even when one is missing. So we could employ quick cross multiplication there, right? So if I want to cross multiply, for those of us who don't know what we're saying, to quickly find the sine of the angle, we have to shift around things. But we could do cross multiplication where the sine of the 180 will multiply by, the sine of the 83 will multiply by 180, and it's going to equal to 289.7 times sine of the angle that we want. So I just set that up. Let me write them down. We're suggesting that 289.7 times the sine of the angle that we need is equal to 180 times the sine of 83. So there it is. We set up that. Remember, the intention is to find this, right? That means at this moment, what you want to do is that you want to divide both sides, right? We want to divide both sides by 287. 289. I keep saying 287, 289.7. And we're almost there. We're not there, but we're almost there. So let's take a look. So the sine of the angle is going to be this value, 180 times the sine, make sure you're touching the right things, the sine of 83, and you're going to divide that by 289.7. So I'm getting 0.6167. So in order to find the angle, I'm going to have to use the inverse of sine. So I'm going to be using the inverse of sine right there. So see there, we're going to be using the inverse of sine. So on our calculator, activate the inverse, the shift, or the inverse, and put 0.6167. And it's going to give us the angle. It is 38 degrees. All right. I could say 38.1. Let me put 0.1. All right. It's going to be 38.1. All right. So we have a 38.1. So let me put it up there so we could see the point I'm making. This angle here is 38.1. Now, what we were saying here is this 38.1, add that to 115, take it out of 360, and there you go. You would get the bearing, right? So we're talking about 38.1. You want to add that to 115, right? 38.1 plus 115, you will get 153.1. This we need to take from 360 to get the bearing. So what is the bearing? Bearing is going to equal to 360 minus 153.1. And we'll get 206.9 as the bearing, right? So as I said, a lot of times what we're given to do, you will not find it straight up. Sometimes you'll find it straight up. And there are multiple ways of getting there. But I would say to us, a lot of times, if you look away from what they ask you to find, you can always find the stuff that you don't need, take them out, and you will end up with what you need. All right, so this one was a nice one. A lot of working. Whenever they give these questions, the further you go in the question is the more they're going towards comprehension and reasoning. And that is when they are differentiating between those who are going to pass from those who will fail. All right, so we have to push to the end. All right, here's another question. All right, let's look to see what this one is saying. This one is a little bit blurry, but we'll go through anyway. All right, so this one says here, the diagram below shows straight roads connecting the towns L, M, N, and R. So I could highlight those for us. L, M, N, R. So they are saying that we have lines, right? We have roads connecting those towns. LR is 18 kilometers, it's given on the diagram. LN is 12 kilometers, it's on the diagram. MN is 10 kilometers, it is also on the diagram. And the angle 25 degrees, which is RLN, is on the diagram. Finally, we got the angle 88 degrees, which is LMN, on the diagram as well. So the diagram is already labeled. And what they want us to do now with this labeled diagram is to respond to a number of questions, right? So the diagram is labeled. Let us see the first question. The first question says, calculate angle MLN. What I would normally tell people to do is, if you're given the angle, please remember that whenever angles are given, they normally use 3 letters, right? If they use 3 letters, the angle is the elbow of the angle. You know, the angle is where the elbow is. It's in the middle. So ML, so this is where M is, and then L, and then N. So this is M, and this is L, and this is N. So they want us to find that angle. They are suggesting that, listen, is the middle. That's what we want. That's the angle that we're interested in. So if you use the three letters, the angle will be in the middle letter, following the flow of the three letters, right? So we need to find this angle here, and I'm gonna just put this there. Take a good look. If you look back at what we were saying in the beginning, we want to zoom in on the triangle with M, L, and N. I will mark this triangle out for you quickly. That's the triangle that we're dealing with, right? So if you look at that, you notice that if I want to find this angle, which is opposite to a side that I know, all right, I could simply look at this angle at 88, and I got the side opposite to it. So whenever I have angles, you know, and sides opposite to each other, and I have 3 out of the 4 pieces, because every side of every angle would have an opposite side. So if I'm seeing that I have the 88 and the 12, and I have the 10, and I want to find the angle opposite to the 10, I could use my sine rule right now. So right now, I could start off by saying 12 over the sine of 88 degrees is equal to 10 over the sine of the angle I intend to find right there. So you could take a look to see what we're saying. When we're employing the sine rule, when we don't have a right angle triangle, this is how we set it up based on the information. If you don't get angles and sides opposite to it, you cannot use this. So let's continue. The intention is to isolate this. But at this moment, we can quickly cross multiply in order to get things out the way we want. So sine of 88 times 10 is going to equal to the sine of the angle times 12. So let's write them down. So we have 12 sine of the angle, this means times, right, is equal to 10 times sine of 88. Now, remember, we want to find this. And you will agree that we need to divide by the 12 right now. So we divide by 12 and balance by dividing by 12 so that it is alone and by itself, right? So we could see that. It's alone, it's by itself. So at this moment, we want to write down that the sine of the angle is going to equal to 10 times the sine of 88 degrees. And you want to divide that by 12. Now we're getting a value out here, 0.8328. When I'm doing these, I'll go up to 4 dp the most, but I'm not going to go less than 3 dp for accuracy, okay? 3 dp is good, we'll round off, and 4 dp is even better. So let us use the sine inverse of 0.8328, and it's going to tell us the angle. This angle is 56.4 degrees. So the angle that they were referring to, I'm going to clean the triangle up right here, is 56.4 degrees. So that's the angle we'd have answered to right there. 56.4 degrees. So again, take your time as you work. Don't rush the questions. Look to see what they're asking. It's going to be the sine rule, the cosine rule, or a trig ratios if right angles are given. 9 out of 10 times, there will be no right angle, so it's going to be sine rule or cosine. All right? All right, let us go further to see what else we have. We want to calculate the distance NR. So I could put on some, I could drop a diagram down here first, right? So let me drop a diagram down here first. We want to find NR. Now, the part of the triangle that I'm going to look at is the part that has NR into it, NR attached to it. So there is a L, there is a 25. I'm going to go back to the diagram. This is 18. This is R. This is 12. And this is N. So you could see them asking us to find NR. It's basically the same situation that we have been dealing with, an angle between two known sides. Or we could say that we have everything in the corner L. The moment you have that, it's going to be the cosine rule. So here's the diagram itself. What I was saying was they're asking us to find this. But they gave us this, this, and the angle here. So whenever the angle is between two known sides, again, we simply use the cosine rule. So let us go and use it. So the cosine rule says that NR square will equal to 12 square plus 18 square minus 2 times 12 times 18. And you want to multiply this by the cosine of 25 degrees. So right there about, we want to just make sure that our check-ins are good. So 12, 12, 144. 18 square is going to be 324. And then I want to put everything here on the calculator all the way down there at once. So -2 times 12 times 18 times the cosine of 25. And we're looking to subtract 391.5. 144 plus 324 minus 391.5. And this is giving us 76.5. Now to find NR, because NR actually had a square on it earlier, so we'd have to take the square root of both sides. So taking the square root of 76.5 is going to give us about 8.75 km, right? So answer for this part is 8.75 kilometers. And there it is, we would have found the distance NR. If you look back at the working though, we are using cosine and sine a lot, all right, as we go forward to solve these problems. So take a look at it, reflect on what you have been doing, what we have been doing, what we have been looking at, and we definitely will see that we're utilizing the same skills over and over. This final, I think it's final, yeah, this final question for this final part for this question is suggesting that we determine the bearing of tone R from tone L, R from L. So you want to note the from L. So it's R from L. Let's go to the original diagram. R from L. R from L. All right, so R, let me clear the diagram up so that we could see where R is. So R from L, I will jot my bearing in a blue. All bearings are from the north. So this is L. So from the north line, clockwise until you reach a line that leads to R. We want all of those angles. And when I said all of those angles, 50, 56.4, 25, all of that angle would have made the bearing that we're looking for. Take a good look. My green here, my big green spot, would have been all the angles that we already have. All right, so all we have to do is to add them up to get this. So sometimes it's a very easy process. So it's going to be 50 plus 56.4 plus 25, right? And we would have gotten 131.4 degrees. And that's the bearing of R from L. Bearing of R from L, all of that. Adding up all of those going around. All right, let's look on the other question. So here's another question here. It says, from a harbor H, the bearing of two ships Q and R are 69 and 151 degrees respectively. You do notice that 69 is on the diagram. 151 is not there. So you're going to have to make sure that you're aware of that. Q is 175 kilometers from H. So Q is 175. I could put that on 175 from H. While R is 242 from H. So we got the R. I put on the 175 for myself quickly there. All right, let's see what they want us to do. The first question is asking us to come to the diagram above to show the information given. 1 mark. There's only one thing missing, and it is the bearing 151. But if you read, it says from a harbor H, the bearing of two ships Q and R are 69 and. So the other bearing is coming from the same place here. So it's going to be from the same place here, coming around here. And all of that is going to be 151 degrees, right? All of that is 151 degrees. That new bearing that I just put there. So complete the diagram though, given the information. So that was the one information that was missing, and the 175. So we put on the 175 and we have everything to go. You would have collected 1 mark for that. Now they're asking us to calculate QR, the distance between the two ships to the nearest kilo. So this is the first one since night that they're giving us that direct information, instruction rather, to calculate to the nearest km. And when you see questions asking you to put your answer to the nearest kilometers, it is asking you for the nearest whole number. So this question is about whole number. So we're not going to submit any decimal for the final answer, right? So let us see QR. Now I could draw this diagram quickly for us down here. So we have that. All right. This is R, this is Q, this is H, this is 242, and this is 175. The angle though needs to go there. So if you go back and look, it's the same principle like a question before. Two bearings overlap. If I want to find the angle right here, it's going to be 151, which is the bigger bearing. I'm going to take the smaller bearing from it, 65. So 151, take 65 from it, and I'm left with 86. So the angle between them right here is the 86 degrees. I can utilize that 86 degrees to solve. Oh, this is not 65, it's 69, okay? This is a 69, hold on. This is 69. So let me write this back, 69, right? So we have 69, let me put it, 151 minus 69, that's 82 right here. That's 82 degrees right here. There we go. All right, so 82 degrees, 69, 151, good. All right, so down here, I could put on this, which is 82 degrees. And from here now, you can see that it's very similar. I want the side opposite to this, right? So we start off by saying QR square is equal to 175 square plus 242 square minus 2 times 175 times 242 times the cos of the angle 82 degrees. So it's a matter of calculator now. 175 square is about 30,625, and 242 square 58,564. And then we're going to put -2 times 175 times 242 times the cosine of 82 degrees. And we're getting -11,787.96. So let's just work this out. 30,625 plus 58,564. Want to take 11,878, 11,787.96 should say, and I'm looking at 77,401.04. So if I'm going to find QR, I'm going to have to take the square root of that. So the square root of the 77,000 will give me 278.2, right? But remember, the question said to the nearest whole number. So it is 278. Nearest whole number, that's the nearest kilometer. So I normally put on my labeling here, right? So 278, I want to put it on this here. All right, so there it is. That's 278 kilometers for that. All right, so as you go, again, it's the cosine rule again. And this was because of the information, how we got it. You realize that you have everything in the corner H, meaning you have an angle between two sides at H right there. So you were able to use the cosine rule to just ease yourself out, all right? Collecting full marks right there with your working. And this last piece of response is very important because they did say to the nearest kilometer, which means to the nearest whole number, right? All right, so let us continue working. How far due south is ship R of the arbor H? All right, let's go to the original diagram to talk about this. How far south? Now, whenever you get questions and they're talking about east, west, and so on, when they said how far south, then what we're going to end up getting is a right angle triangle because it is suggesting to us that we need to come down. We're going to be coming down south. And you're going to come down just enough to line up with R. You're going to come down the right place such that you could go east and go all right into R. So that's the idea you want to think about, right? Coming down south and then heading east. That means we're going to have a 90-degree right here, right? Then now, when the question says how far, that means they want you to find this distance here. This distance from H to here. This is the distance you intend to find from H until you reach the required distance to go east, right? Now, we want to think that if I come south, it means that if this is north and this is south, and I started my north line here and I'm traveling south, this degree is 180 degrees. We want to appreciate knowing that. So the fact that that is 180 and 151 came here, I am able to find that little piece. So if I take 151, if I say 180 and I take 151, right? 180 and I take 151 from it, I am left with this little piece as 29 degrees. Why am I doing this? I'm doing this because I need, sorry about that, because I need the angle to help me to find that distance here that I call X. We need this distance, right? So that distance is an adjacent side to the 29 degrees, and we have the hypotenuse. So you want to go back to your trig ratio. And why trig ratio is because we actually have a right angle triangle, right? So because it's a right angle triangle, then we're looking at that. So we could work it out right here. So katoa, which one of these would include an adjacent side and the hypotenuse side? It's going to be cost. All right. So we're talking about the cost of an angle in a right angle triangle is going to be the adjacent side divided by the hypotenuse side. So in this case, the cost of 29 degrees is going to be X. I'm calling that X. That's the side that I need. That is how far south I need to travel from H over 242. As you could see, if I multiply both sides by 242, it will cancel on the right side, leaving X. So my answer will be, if I can find, so X basically is going to be 242 times the cosine of 29. And I'm looking at 211.7 kilometers. So you want to look if there's any special instruction. How far due south is ship R from H? So when they said how far due south, all they're referring to, how far do you need to travel south? From H, how far do you need to come down? So this is saying 211.7 kilometers. You come south that much distance, then you will be lining up with R across. All right, so the answer is 211.7 kilometers. All right, let's continue. We have more questions looking at. All right, so this question, it says, from Harbor H, the bearing of two buoys S and Q are 185 and 311 degrees respectively. The 185 is there. They didn't mark fully the 385, but we're told that that's the bearing of Q from H, the 311, this one. The other one was marked, you could see that, which is this one, right? All right, so let us continue reading. Q is 5.4 kilometers from H, while S is 3.5 kilometers from H. All right, so I would want to employ some labeling here. So it says Q. So let me put on the labeling here first. It says Q is 5.4 kilometers from H. So this is 5.4. All right. And then it says S is 3.5 kilometers from H. S. So this is 3.5 km. All right. So we have those. And it seems as if you're setting up yourself to use cosine rule again. You notice the idea keeps repeating. So let's see what they're asking in reality now. On the diagram below, which shows, right, the sketch of this information, insert the values, all right, of the marked angle QHS. So the first question, they want us to find the angle QHS, which is this angle I'm going to put in green. They want us to find this right there. Remember though that they left off a very important information. They left off this, that we got the bearing of Q from H, which is all of this. All right, so we got all of that. So, and that was 311 degrees. If I take out 185 from it, the remainder will be the green angle. And you notice we have done quite a number of questions that they actually expect us to work those. So this is 126 degrees here. So that's what they're asking, right? This is asking that. So it's 126 degrees. Calculate QS, the distance between the two boys. Well, you could see QS. I could drop a diagram down there. Or we could work QS right beside it. So we want to work out this distance from Q to S. But you do realize that we have an angle between two sides again, so it's a cosine rule that we want to use. So we are suggesting that QS square is equal to 5.4 square plus 3.5 square minus 2 times 5.4. Okay, I need some space. All right, let me not put it there. Let me go and put it where I have this space. Let me go down here. So let me get a diagram down there for us so that we could work with it. All right, so I'm going to put a diagram. All right. So I'm dropping a quick diagram, not a big one. Q, S, that's what we want. This was 1, 2, 6. This is 5.4. This is 3.5. So we were saying that QS square is 5.4 square plus 3.5 square minus 2 times 5.4 times 3.5 times the cos of 126. Let's try to put our numbers together. 5.4 square, it's about 29.16. 3.5 square will give us 12.25. And then negative 2 times 5.4 times 12 times 3.5 should say, times the cosine 126. And we're getting a positive 22.2. Let's put it together. 29.16 plus 12.25 plus 22.2. We have a total of 63.61. So to find QS, we take the square root. And this is giving us it's giving 7.9755, right? So this can be rounded off to approximately 8 kilometers. Or it could have been 7.98 kilometers, right? All right, so 7.98 kilometers or we could say 8, depending. So any one of those would be good. All right, so the question went further. It says, calculate the bearing of S from Q. So we have to look, the bearing of S from Q. Bearing of S from Q. All right, so let's look at S. All right, let me minimize this so that we can see. All right, there it is. All right, if we're gonna look at the bearing of S from Q, let's draw our bearing. Because it says from Q, you want to go at Q. So the bearing of S is gonna be us doing this, all of that. So we want all of that angle. But I do know some of that angle already. The only part I need to know is the part that's in the triangle, because if I should say 360 minus 311, I'm gonna get 49 degrees to be here. Why am I using 49 here? Is because co-interior would suggest to me that this angle here and 49 here, they are co-interior. So it simply means then I could find that angle and I would have part of the bearing. And the only thing I'm going to need to do is to find this piece in the triangle that I'm going to put in yellow. And if I add this value that I get here, plus this one here, it's going to give me the bearing that I want. To find that missing piece up there in pink, it's going to be 180 minus 49. Remember that co-interior angles add to give 180 degrees. So this angle here is 131 already, because I linked it to the 49 to tell me. So the fact that I have that, I just need to find this yellow piece in the triangle. And I'm going to use the sine rule again for the yellow piece. So I'll start off by looking at, let me outline the triangle you're going to use. There is a triangle. So with that outlined triangle there, we're going to be utilizing the sine rule to help us to find the yellow angle. Then we add it to 131 and we're good. So we could start off by saying 7.98 divided by the sine of 126 is equal to 3.5 divided by the sine of the angle we need. We could cross multiply right now to get these out. So 7.98 times sine of the angle is equal to 3.5 times sine of 126. Remember, I need to find this. So I'm going to divide both sides by 7.98. All right, so the sine of the angle that I want is going to equal to 3.5 times the sine of 126. And we want to divide that by 7.98. And we're getting 0.3548. So the angle is going to be the sine inverse of 0.3548. And we'll get the answer. $20.8. So this angle here is 20.8. So then the bearing is going to be 131 and 20.8. So that's what we're suggesting. Based on what the question wants, the bearing is going to equal to this. The bearing is going to equal to, this is 20.8 in here. So 131 plus 20.8. And that's going to take us to the bearing. So it's going to be 151.8 degrees. That's the bearing. So as you can see, how we're working on all of these. The principles are the same. We have to look though. Look out of our eyes, see what they want, and then put together how we are going to go forward. Always. So this is another question, right? All right, so it says here, the diagram below. All right, so it says the diagram below, not drawn to scale, shows the route of a ship cruising, right? 1 second. All right, this is good. All right, so the diagram below, not drawn to scale, shows the route of a ship cruising from Palm City P to Quantown Q, and then to Rivertown R. The bearing of Q from P is 133, and you're looking at that measurement, and the angle PQR is 156. So we got some information already. This diagram is well labeled, so we just have to see what it is that they're asking and do it. First question, calculate the value of angle W. Now, I'm gonna need this angle right here. I need this angle right here. But in order to find that angle, I'm definitely gonna have to find this angle here. But the angle that I want to find is co-interior with 133. So remember, co-interior angles, they do add up, right? Co-interior angles add up to 180. All right, so I could find that right there. So 180 take away the 133. And there are other ways. I could show you another way, but you need more vision to see that. So we're getting that this angle here is 47. So this is 47 here. So then if I link 47 to 56, take it from 180, I'll get this. So that is how I'm going to find W. So W is going to equal to 180 subtract the sum of 47 plus 56. So if I add 47 and 56, that's 103. So basically, we're dealing with 180 minus 103, and we'll get about 77 degrees for W. So if we want to mark W, W is 77 degrees. So W is 77 degrees. Determining the bearing of P from Q. Determining the bearing of P from Q. P from Q. So then what it is they want, this. Mark the angle. Bearing of P, but from Q. So this is Q. If you go to the north, because bearings, all bearing are from the north. So from the north, I'm going to step up a little bit above Q, and then I'm going to do this. You're going to realize that there are two things that you can do. You could add up all those angles going around, or you could pluck 47 from, so I could pluck 47 from the 360, because the bearing that I want is everything except 47 to close 360. So I get 313, that's the bearing. That's one way. I could have also added 180 to the 77 to the 56, and I should still get the same answer. We still end up with the 313. So I'm just saying, depending on how you see the question. If you see the entire angle there as 360 and we want everything except 47, then you could subtract the 47 from the 360. If not, you'd have to pull it apart in pieces, seeing 180, right? Seeing the 180, seeing the 77, seeing the 56, add all of those up, and you'll be getting the same response, 313 degrees. Calculate the distance RP RP. As you could see, again, if I clear the diagram up, all right, so clearing the diagram, they're looking for RP. You can see for yourself that RP is actually, we know everything in this corner. So at H, we have an angle between two sides and we're going across. And you should see from now that we're seeing this a lot. So we could start off by saying RP square is equal to $290 square plus 210 square minus 2 times 290 times 210 times the cosine of 56. And this will take us there. 290 square, 84, 100. 210 square, 44,100. Then negative 2 times 290 times 210, and that times the cosine of 56. And we are subtracting about 68,109.7. Let's put everything together. 84, 100 plus 44, 100. I want to take away 68,109.7. And I'm looking at 60,990.3. So if I want to find P, or RP should say, I'll take the root of that. And I'm getting 245.1 km. So this is 245.1 km. All right. So there it is. We would have found that right there. All right. So that will be all. If you notice, all the questions, we are actually doing the same things over and over, back and forth. If you notice, we have used the cosine rule a lot. These are all exam questions. The sine rule a lot. So it's more about the cosine rule, the sine rule, the cosine rule, the sine rule. If you just scan through all the questions that I did, cosine rule, sine rule, cosine rule, sine rule, no and then trig ratios. Because most times when you're dealing with the bearings, it's not going to end up in a right angle triangle most times. And that is why, as you could see, you're going to have to employ the trig rules to go about doing that. Remember to hit like and subscribe to the channel. Everybody hit likes before you leave. Also subscribe to the channel, and I'll see you another time. So look out for more videos as we will be sorting out stuff. All right.